Correspondence matrices are underrated. Two point clouds can be aligned if either the transformation between the input point clouds or the correspondence between the points is known, and we have observed that correspondence is a more robust parameter for registration as compared to transformations. Deep learning based registration methods such as RPMNet, PCRNet, and DCP learn transformation between the input point clouds. In this work, we show that if these networks are trained to learn correspondence, they can converge faster, can register with higher accuracy, and can register partial point clouds even at higher misalignments. Here onwards, we denote a network trained to learn transformation as method, while the same network, when trained to learn correspondence, will be noted as method correspondence. For method correspondence, we predict the correspondence between the input point clouds based on the similarity between the per point features. This predicted correspondence is compared with ground truth using cross entropy loss, hence treating registration as a multi-class classification problem. It can be observed that even though DCP correspondence was not explicitly trained to learn transformation, DCP correspondence has lesser rotation and translation error. Here, setting 1.3 is similar to experimental setting suggested by the authors of DCP. Even for this setting, DCP correspondence is more accurate and it converges at a faster rate. For RPMNet, we see a similar trend as in DCP. Here, we also compare RPMNet and RPMNet correspondence using chamfer distance and see that RPMNet correspondence performs better. For the experimental setting suggested by the authors of PCRNet, we observed that both PCRNet and PCRNet correspondence show similar performance. Although for a smaller number of points, PCRNet correspondence gives more accurate results even for arbitrary misalignments.